Okay, welcome back, class. So after seeing, in the previous session, we have seen the different kind of stage that we can have for textual as well as for speech data. Now we are going to very briefly, we're not going to go deep into them. We are going to briefly see the technologies and the applications that we have in natural language processing. Most of them we have already seen them while discussing the introductory part, but let's try to see each of them, very briefly. One is a speech recognition. So as I said, speech recognition is concerned about converting a sound into a text representation, okay? So whenever you speak, such kind of application, which we call a speech recognition system, convert the sound into a textual representation. But mind you, the task is not as simple as we speak. For instance, if you hear this sound or if you receive this audio, what would be the text? What if you receive the sound C? What do you do? What would be the text?
So in which language?
In English.
C,
what would you write?
letter.
The letter C. Any other?
Is there a C? Is there a C letter only?
It can be
difficult
any of these, right? Now,
Yeah.
how do you recognize which one is which? Okay. What if first I say I, then you receive the sound C?
Okay, then we can take the second one.
Okay, all these are possible. But the study of the language will tell you that the word I cannot appear with the word C, because if you do that, it would be I see, or it would be I see, or it would be I see. Now, which one is the most frequent one that you see in the language?
The third one.
The third one. You see, this is what we mean by looking into the context. Whenever a word appears, whether it is in a written or a spoken form, it occurs with other utterances. It occurs with other constructs. So whenever you have a larger context, understanding or identifying what has been said would be much easier. But the task of a speech recognition is to convert a sound into a written form. So a dictation system or a command control system, like if you want to order your phone using a sound, internally what it does is it converts the sound into the text, and the text is going to be interpreted into an Android command or an Apple iOS command. It would be converted into such a command. So command control system or a dictation system are good examples. The reverse action is what we call a speech synthesis, or we call it TTS, to mean text-to-speech system. And the task is, whenever something is written, you are going to convert it into a sound form. And we have a very simple example. I don't know, we have seen earlier. What do you do if you receive the word, this word? How do you pronounce it? Converting the text into a sound. Are you going to say Gana or Ganna?
It's difficult. We have to see the context or dependent on
exactly.
related
But
words.
what if you have, and let's be honest,
then we pronounce it as a ganna.
Ganna እንለዋለን አይደለ? Because now we know that it's holiday. አይደለ? So converting the text into a sound is also a challenge. What if you have the word, this word? Are you going to pronounce it as read or read?
It depends on the individual.
Exactly. If you say I have, then you have to say I have read. But if I say this, then you have to say read. Please read the book. You don't say please read the book. So based on the context, the way you pronounce it would be different. So as I said, whenever you get a text, converting it into a sound or a speech is one other kind of application. And we call this one a speech synthesis, or we call it text to speech system, converting the text into a speech system. So understanding the internal representation of a word and converting into a sound is what we call TTS, or text synthesis. We also have what we call text categorization, which means if I give you a document or a text, grouping it into or classifying it into, for example, if it is a news, you can say this is politics, or you can say this is a sport, or you can say this is entertainment, or anything. To perform this job, you have to look into the words that are used in the document. For example, if it says a goal, a player, a match, oh, this is a sport text ማለት ትችላላችሁ. What if it says music, theater, artist, then you say this is entertainment. So doing this requires you to analyze the words in the document. So for example, news classification or text categorization is what we call one type of NLP application. We also have text summarization, which we are going to have a chapter for this one. Converting a larger document or compressing a larger document into a smaller size is what we call text summarization. But mind you, when you do that, you have to make sure that the relevant part of the documents are not missed. The relevant information is not missed. But like you might have a 10-page document, but converting into a half-page document might be very important for people who do not have time to read it, okay? So text summarization is one very important NLP application. And as I said, we have a chapter for that in this course. We also have indexing. Indexing is concerned about, identifying or extracting relevant words from a document. Mind you, if I give you a document, the document is filled with many words. Some of the words, we call them content bearing. Some of them, we call them stop words, okay? You know what a stop word is, right? From your information retrieval course. I don't know.
Yeah.
You know, stop words means they are non-content bearing words, like the word there, the word a, the word
Is.
on, the word for, the word on, is. We call them stop words.
Stop.
Because they don't contribute to the meaning of the document. Rather, their function is linguistic, okay? So from the document, identifying words that are, content, that are having a meaning, that are topic words, is what we call text indexing. And doing that requires an NLP application. And the reverse action, which is text retrieval, is also another NLP application, which means based on the index and the keyword, identifying a document that explains more about those words or those query words is what we call information retrieval. So IR is an NLP application. Indexing is also an NLP application that we have. The other one is information extraction. As we said, you might have a very big document, but from that big document, you might not be interested about each and every word, each and every component in that document. Maybe you are interested to identify only some part of it. For instance, you might be interested to identify date and time from the document. Or maybe you are interested to identify email addresses. Or maybe you are interested to identify telephone numbers. Or maybe you are interested to identify name of a person only, which means the other part of the documents are not relevant to you. So we call that information extraction. So from a larger document, again, we are interested to identify only few segments of it that are relevant to us. So relevant information, pieces of information are discovered and marked for extraction. Like, for example, identifying the topic, named entities, or name of a place or a company, a simple relationship, or like identifying only numbers or a price, or identifying, let's say the score of a game and stuff like this are said to be information extraction. Mind you, information extraction is wide. So you don't know which information that you need. For instance, what if you want to send an email for any person who has an email? The first thing that you have to do is crawl an email, identify an email. And to identify an email, you have to know how email addresses are written, right? Email address, there is a name, there is an @, there is a provider or a host, then there is the ending, whether it's com, net, org, or edu, or something like that. So identifying an email is a complicated task. By the way, we are going to talk about that in text processing. Like, for example, anything that has the @ is not an email, we know. So there is something that comes before it, there is something that follows after it. Even the thing that comes before it, or a text that comes before and after it, has its own structure. So knowing that structure to identify an email address, or knowing a structure to identify a number, or a year, or a date, or a number, or like a price or a fraction, is what we call information extraction. And you also know about data and text mining, which means identifying new knowledge from a data or from a text is another NLP application that we have. A question answering is another very challenging NLP application, which means a person or a user is going to ask a question and your system is expected to give an exact answer. Like you can say, what is the price of coffee today? Then you don't need the whole analysis of the market. You don't need how much quintals have been supplied. What you need is the exact price. And such kind of question answering systems are, NLP applications, which are very challenging. Report generation is another NLP application that we have, which means from statistics, from a database contains only a relational data, producing a report, a written narrative is what we call an NLP application. And to do that, you have to use combination of words, you have to use combination of numbers. And doing that is another NLP application. The other one, if you see a spoken dialogue system, I'll take you back a few slides, is a combination of automatic speech recognition. Let me put it in such a way. This is concerned about automatic speech recognition, or ASR, and this is concerned about TTS, or text-to-speech system, or text synthesis. So if you combine these two systems, let's go back there. If you combine these two systems, you see, if you combine these two systems, a speech recognizer and speech synthesis, what you are going to have is a dialogue system, which means you're going to have a speech. Sorry, let me clean the window. You have a speech in here, okay? You have a speech in here. The speech is going to be converted into the text, and this text is going to be converted to a speech. So at the end, what do you have? You're going to have the two speech input and outputs, which means a speech is going to come from the human being to the machine. The machine is going to convert it to the text. The text is going to be converted into a response, and that response is going to be converted into another speech output. And when you do that, we call it a dialogue system, which means you are conversing with a machine using a speech. And that's what we mean by a dialogue system. So a dialogue system will take a speech sound and also produces a speech sound. But in here, we know that there is an intermediate process of converting the speech into a text, okay? Then generating a response for that text, and that response is going to be converted again into a speech using a text-to-speech system. Here we have an automatic speech recognizer, which converts the sound into a text. Here we have a TTS, or a text-to-speech system, which converts the text into a sound. So when you combine these two, we call it a dialogue system, because you are conversing with a machine using a speech. The other one is a translation technology, a machine translation. And this technology translates a text, or some part of the text, from one human language to another human language. So a machine translation system would convert a text, for example, from Afan Oromo to Amharic, or maybe from English to Amharic, or any language. So converting a text from one language to a text in another language is what we call a translation system. But mind you, whenever you do that, all the different levels of language would be used in here. You have to be concerned about morphology. You have to be concerned about, all these things are very important in this task, okay? You have to be concerned about morphology, okay? You have to be concerned about syntax. You have to be, syntax. You have to be concerned about semantics. You have to be concerned about pragmatics as well, okay? You have to be concerned about even discourse. You have to be concerned about all these things, because you have to understand the morphology of the source and the target. You have to understand the morphology of the syntax and the syntax of the source and the target. You have to understand the semantic of the target language and the source language. You have to understand the pragmatics of the source and the target language. As we said earlier, for instance, if what I have given you as a sentence is, and now, many tabas. እንደዚህ ብዬ በሰጣችሁ you know that when you make a translation, you have to understand the pragmatics of Amharic. Then you have to say, so what? Okay? And if you say, what shall I cook? Then it means you missed everything. So whenever you are concerned about translation, you have to touch upon morphology, syntax, semantic, pragmatics, and discourse. All these things are going to be, analyzed somehow in the process. Okay? So I think it's better to, okay, let me see how many slides that we can cover in the remaining time. Okay, I think we can go through some of them. Yeah. So saying this much about the different kind of technologies that we have in natural language processing, let's talk a little bit about the methods and the resources that we have for NLP or for computational linguistics. When it comes to the methods for language technology, it comes from many different disciplines. Mind you, NLP is a type of artificial intelligence, and artificial intelligence is the use of computational systems, either devices as well as soft skills or programmings or computer programs that are going to manipulate things in an intelligent way, just like human beings, do the job. And to do that, we borrow or we use techniques and resources from many different disciplines. The first one is we have to borrow or we have to have some knowledge about computational and theoretical linguistics. Mind you, since we are working on a language, you need to have methods and resources from a linguistic perspective. So computational and theoretical linguistics are going to serve a lot. Mind you, whenever you talk about morphology, whenever you talk about syntax, we're talking about linguistic knowledge. So theoretical and computational linguistics will play a great role. So methods and resources from theoretical and computational linguistics is going to be used a lot. The other one is we are going to use, conventional computer science methods like data representation, data structure, data storage, data organization are going to be used. So basic computer science techniques and resources are going to be used. For instance, for string manipulation, what you have to use is a programming language. For instance, to represent the data into the computer storage, you're going to use different kind of file organization. You're going to use different kind of data structure. And that is borrowed from a computer science discipline. We are going to also use what we call the concept of data science, because in language, we are going to use a huge amount of data. And whenever you have a huge amount of data, then you have to borrow some methods and techniques from data science. You have to deal with big data analytics. And to do that, knowledge from data science, knowledge from data analytics are going to be used a lot. The other important method that we have is mathematics, which includes statistics for that matter. Most of the thing that we do is manipulation, but whenever you do manipulation, you have to use mathematical models, like model of probability, model of uncertainty are going to be used in here. And to use that, we have to borrow some techniques. We have to borrow some resources and methods from the mathematics field. The other one is if you are going to be concerned about, especially for speech processing, speech production, then we have to use some knowledge from electrical engineering, because the production of a sound by using a machine needs some engineering knowledge. And that electrical engineering concepts or methods are going to be used a lot. The other and the most important one, which is really very difficult to frame, is psychology. Language is about a cognitive process, and that cognitive process is going to have some, psychology concepts in here. So understanding the psychology of a language, a cognitive process of a human being is very important. So whenever you do NLP application, at some point in time, you are going to be, touching up on all these fields. Computational and theoretical linguistic, computer science, data science, mathematics, electrical engineering, and psychology are going to be touched upon, okay? So saying this much, let's spend some minutes on discussing about the resources and the methods from, the known fields. For example, we are going to make use of generic computer science methods. For instance, we're going to use programming language, which are generic computer science, what we call resources or methods. Like, for example, we are going to use either Python or Perl or maybe Java or any other programming language. Mind you, these programming languages are not typically developed for NLP, but we are going to use them. to do natural language processing. So the algorithms for, like, generic data types, or software engineering methods for structuring and understanding user requirements for developing an application are going to be used. Like, you can use either, let's say, a waterfall or an agile method of programming for this purpose. So this is a computer science or a computer engineering methods. The other one is we also use a specialized algorithm. Mind you, whenever we say specialized algorithm, it means that the algorithms are typically, mind you, typically developed for NLP application. They are not used for anything else. For example, you can have an algorithm to produce the square root of a number. You can have an algorithm to produce, let's say, the sum of a list of numbers, or the mean or the median of a list of numbers. This is a generic application. You can use it for many other specific applications, like having a mean of a number can be used in mathematics, in statistics, in biology, in education. You can use it for many other application areas. But some of the applications, so some of the algorithms are typically developed for NLP application. Like if you see an algorithm for parsing, an algorithm for translation, an algorithm for morphological analysis, an algorithm, for example, to create a past tense of a word, an algorithm to assign a part of speech for a word, like to say a word is a noun or a verb or an adjective. Such kind of applications are not generic. They are typically or specifically developed for NLP application. And there are many that we are going to see throughout this course. The other one is we also use non-discrete mathematical models, like statistical techniques are highly used in NLP application, because in a language, we are concerned about the use of some construct in different instances. And to decide which one is the correct construct or the correct context, the correct sense of a word in a context, we have to look into its past usage. And that past usage is going to be analyzed using a statistical technique, like we can use conditional probability. We can use, the Markov chain model to see which one is the most appropriate construct. If you remember, we have said, we had some example earlier, right? You can have the word I, then there might be different options. You can have the word C, or you can have CEA, or you can have CEE. Now, to decide which one is the correct sense for the computer, it has to look into the statistics. It has to look into how many times the word I occur, and how many times the word I occur with C, how many times it occurs with CEA, or how many times it occurs with CEE. And whichever is the highest is going to be the best decision or the best prediction. I'll give you one very simple example. When you write a text message, we know that your phone is going to recommend the next word, right? So after you write the word I, then it might give you an option. It might be I will, I am, or I can ሊሆን ይችላል. Any of these are all the possibilities. But which one is the most frequent one? So what it does is it will count how many times this occurred, okay? Then it will count how many times, I will occurred, how many times I am occurred. It's going to see how many times I can occur, okay? Then for instance, if this occurred 200 times, and if this occur 120 times, and if this one occur, let's say 80 times, or let's say 280 times, 280 times, it tells you that the word I occurred a total of this, right? 200, 280, 480, 500, 600 times. The word I occurred 600 times, but from these 600, it occurs with can 280 times, it occurred with 120 times, it occurred with will 200 times. So the idea is, in case, after having these statistics, in case you have written the word I, then the computer, logically, based on the statistics, will make a recommendation. ምን ይለናል? መጀመሪያ ካን ሊሆን ይችላል። ካንን ካልመረጥክ then it will be will. willን ካልመረጥክ ደግሞ it will be an ብሎ ኦርደር ያደርግልናል. And this is based on the statistics of previous use. And making such a decision is part of a statistical technique. So it has become especially successful in speech processing, information retrieval, and automatic acquisition of language model. So of other methods like neural networks are going to be used really high from a machine learning domain. They are going to be used along with this non-discrete methods or statistical methods. The other one is we also use methods and resource from logic and linguistic formalism. For instance, if you want to do semantic analysis, what you need to have is a logical formalism, because logic is concerned about how things are related to one another. And if you see semantic, semantic is concerned about how adjacent words are related to one another to give a specific meaning. So you have to look into logic. When we study word sense disambiguation and semantics, we are going to see how logical relationship between words can be formulated. We also have to use linguistic knowledge. Mind you, since we are working on language, knowledge from the linguistic domain is very important, like knowledge like dictionaries. Like dictionary is a knowledge, a linguistic knowledge that gives you a word and its meaning, or a translation from one word in one language to a translation in another language. Like rules of a grammar, rules of semantic interpretation, rules of pronunciation, rules of intonation. All these are linguistic knowledge that we cannot get from anywhere else. For instance, in English, we have such kind of a structure. We have a noun followed by a verb, followed by a noun is a structure. Like you can say, the boy likes the girl, okay? If you have this sentence, it tells you that the boy is a noun, likes is a verb, the girl is a noun, okay? So as you can see, the structure is noun, verb, noun. But if you change it, this one to Amharic, what would be the sentence? ምንድነው የሚሆነው? ልጁ
ሴት ይወርዳል።
ዋይ እንደው ልጅቷን እንበለው ሴት የሚለው ቀርም አይደለ? እንደዚህ ሆነ ማለት ነው አይደል? ልጁ ልጅቷን ይወዳታል። ይሄን ጊዜ ምን ሆነ ማለት ነው? It's a noun followed by another noun followed by a verb. አያችሁ the structure? So knowing that in Amharic, a noun, then a noun, and a verb are going to follow up in such a sequence. And when it comes to English, it is a noun, a verb, and a noun is very important. So in a way, we call it, this is a subject, an object, and a verb in the እዚህኛው ላይ ደግሞ we call it a subject, a verb, and an object in the As you can see, the order of the words for a grammar for English is SVO, but for Amharic it is SOV. So this is a linguistic knowledge. You cannot get it from anywhere else. So the linguistic knowledge is very important to do computational linguistic or natural language processing. So we borrow a lot of knowledge from the linguistic. The other one, most especially these days, most of NLP applications are developed using a statistical method, using a machine learning approach. And that machine learning approach depends on past data, okay? It depends on previous data that you have. The idea in here is a machine cannot directly learn the rule from the human beings. Most of the time, the knowledge of that language are going to be captured in a document. For instance, you might have thousands of documents. And from those thousands of documents, the machine can learn the list of words that you have in the language. It can learn the sequence of words in the language. It can learn the part of the word that frequently is the ending of the word. For instance, if I give you a huge English document, from that document, you can collect words that end with ing. Okay, so it tells you that if there are many words that ends with ing, then there is a pattern. In machine learning, that's what we know. If something happens again and again, then it must indicate something. So if you have many words that end with ing, this is a new knowledge that you have. And to get this one, what you need is maybe, let's say, I might give you, let's say, 10,000 documents. And from these 10,000 documents, you can collect list of words, mind you. Okay, you can collect list of words. Or from this one, you can collect list of phrases. Or from this, you can collect, for instance, most frequent ending of a word. Okay, you can collect this one, or you can collect the most frequent starting segment of a word. You might find the word "an" is the most frequent prefix that I have in the word. What does it mean? Then it means there is some linguistic knowledge on this part of the word. And to perform all these things, what do you need to do? You need to have a corpora. Mind you, for example, let me have David. What language do you speak? David. What language do you speak? David? Samam David. What language do you speak? Okay, Zanaba.
Rabbit, Sidama.
Sidama, Adala. Now, how many words do you have in Sidama language? How many words do you know?
What?
How many words do you know?
Yeah, many.
Yeah, many. Just give me an estimate. It's not a test. Just give me an estimate.
Okay.
Gabay,
President.
how many words is the Zumbala, a rough estimate. Do you know like 20,000 words? Okay. Now, how many years that did you take to know all these words? How many years did you take to know all these words?
Yeah, many.
Many years, Adala? Like 20 plus years. But if I give a machine, okay, if I give the machine 10,000 documents, then from these 10,000 documents, within seconds, okay, within seconds, it can identify, like, let's say, maybe 50,000 words within seconds. So a corpus is very important. Using a corpus, you can identify many knowledge of the language. Not only the words, you can identify list of phrases, you can identify frequent endings, you can identify so many other constructs from a language. So corpus is very important. So corpora or a corpus tool is a large collection of application-specific, a generic or specific collection of either it can be a spoken text or a written language text. And once you have that one, using those corpora or collection of data, you can actually develop a statistical or a rule-based models, because it will give you a lot of knowledge. So what we call corpora is a large collection of either a spoken or a written knowledge that you can use to extract knowledge from, okay? And these are very important resources that we have in natural language processing. So that would be it for today. Next time, which means tomorrow, we are going to meet tomorrow at 9 a.m. in the morning. We are going to discuss some of the approach that we have in NLP. Majorly, we are going to focus on a rule-based and a machine learning approach. So that's what we are going to cover tomorrow, okay? Thank you very much for today.